As you know, the so-called Big Bang Theory is the currently accepted hypothesis of the formation of the universe in the scientific community. Is this really such a simple question, though? In addition, hasn't this theory been questioned by the latest research? Has there really ever been a Big Bang? If it never happened, what else could have happened? In today's video, we want to think about all this with you. The Big Bang is not an explosion in the conventional sense. Some non-scientific people often say they don't believe in the Big Bang. This is because we all think that explosions should be the phenomenon that destroys everything, so we can't understand how the destructive phenomena caused by explosions can produce things, let alone how explosions can create the orderly universe we see now. However, this is an error of expression or understanding, which may be caused by imprecise terminology. In fact, it is not quite correct to call the Big Bang an explosion. For example, the Big Bang has nothing to do with the chemical explosions we see in our daily lives. The so-called Big Bang refers to the singularity, the phenomenon in which all the matter in the universe is initially extremely compressed to a small point and rapidly expands. However, this theory was not immediately accepted by everyone. In the beginning, the idea that the universe was eternal and infinite dominated the scientific community. This is also known as the steady-state cosmological theory. It wasn't until important evidence of cosmic microwave background radiation and cosmic expansion was discovered that proponents of steady-state cosmology like this one had to embrace the Big Bang theory. Because the Big Bang theory can explain these phenomena well, but it is completely inconsistent with the steady-state cosmological theory, the two theories can be said to be opposites. In the last decades of the 20th century, most of the observed phenomena could reasonably be justified by the Big Bang theory. In addition, it is hoped that those unexplained phenomena will be explained as soon as possible. However, as time passed, more and more problems began to arise. So we may soon need to reassess our existing view of the early universe. Our first major challenge is to discover the large-scale structure of the universe. If matter were just scattered chaotically in expanding space, the universe would be in a rather chaotic state. In other words, in the universe, the largest structure connected by gravity is galaxy clusters, which scientists believe are evenly distributed in space. However, this is not the case. There are some huge structures in the universe, the fibrous structures that we have introduced in the past, that stretch for billions of light years. This is a structure formed by thousands of galaxies brought together by some unknown force. Our galaxy is located almost at the center of the KBC void, which refers to a huge hole in the universe. It does not have any fibrous structures around it. In addition, the singularity of the birth of the universe itself has its own puzzling problems. In theory, the singularity is characterized by three parameters, namely infinitely small volume, infinitely large density, and temperature. However, the latter two parameters are actually contradictory. If the density is infinitely large, it means that the entropy will approach zero infinitely, which also means that the temperature will be close to absolute zero. Even if we know how infinitely large temperatures and densities are compatible, we have no way of knowing what exactly the definition of singularity is. We can know the state of the universe 1 second after the Big Bang and the singularity collapsed, but it's impossible to know what happened before that. Because of this, scientists worry that the mystery has not been solved at all. According to the Big Bang theory, we can say that the expansion of the universe must be completely linear. In the beginning, the expansion speed is very fast, it can be said to be a real explosion, but over time, the expansion rate gradually slows down. While this was the case when the universe was first born, an unexpected factor emerged billions of years ago. This factor is dark energy. Since then, the universe has been expanding at an accelerating rate. In other words, the rate of expansion increases over time. What exactly is dark energy? We don't have any clues at the moment. So, if someone asks what existed before the Big Bang and what caused it, even smart scientists can't answer that question. One of them is the inflationary period of the universe. This was a brief period after the birth of the universe, and the whole period was less than a second. At this time, it is said that the universe has reached a high temperature with a number of 28 zeros. At present, there are about 200 mathematical models of the expansion of the universe at this stage, each with its own unique characteristics. According to scientists, if we want to understand why the universe is the way it is, we need to look for reasons during this period of inflation. However, there have always been contradictions, and even Paul Steinhardt, a representative of the modern era of inflation, abandoned the theory and began to build his own model. Simply put, modern Big Bang theory has more problems than scientists expected. But would that be a reason to abandon the theory? Are there any other alternatives to this theory? When we discuss generally accepted assumptions and theories, it is necessary to understand why. In the scientific community, when there is one hypothesis that explains the most common facts and phenomena more reasonably than other theories, that hypothesis becomes mainstream. The Big Bang theory can be said to be the same situation. Yes, as we have pointed out, there are some loopholes in this theory, and there are many contradictions. But, overall, this theory has its role. We have also observed other phenomena that fit this theory, such as the cosmic microwave background radiation and the phenomenon of distant galaxies slowly moving away. There is no other theory to explain these things. That's all for this video. Thank you very much for watching. If you have any questions, you can leave a message in the comment area below.